Fractions and decimals. There are two types of decimals: terminating and repeating. And just as the terminator could bring your life to an end, so could a terminating decimal. It brings the digits to an end. So terminating decimals are just decimals that end. So an example of that would be if we had 4/5, we could do 4 divided by 5, and 5 won't go into 4, but it will go into 48 times, and notice we end with a remainder of 0. So terminating decimals are decimals that end, and if you divide them out, they have a remainder of 0. Now repeating decimals can be a little bit of annoying, because repeating decimals can go forever and ever and ever if you don't put a stop to them. Well, there's no stopping them, but you can put a bar over them so that they end up stopping. So repeating decimals can be written as fractions, and fortunately a bar is placed over or above the repeating digits. So you don't have to keep writing out 2.3333333 forever and ever. You can put a stop to it and just put that bar. An example of a repeating fraction is 11/9. And if we do 11 divided by 9, 9 will go into 11 one time. Subtract. We get 2, bring down the 0. 9 will go into 20 two times. We get 18. Bring down another 0, and what do you notice is happening? We keep getting the same remainder over and over again. Well, I see what's happening, so I'm going to go ahead and stop it and just put it equals 1.2 with a bar over the 2, because I know that 2 is going to repeat forever. Now this is an instance where only one number is repeating. And that's not always the case. Sometimes you'll have 2 numbers repeat, 3 numbers repeat, even a string of 4 or 5 numbers that can repeat. So let's do an example where it's more than one digit that repeats. So 13 over 22. If we do 13 divided by 22, and notice that I say it forwards and I write it backwards. So 13 divided by 22. And I'm going to put that decimal straight above the end of my whole number. 22 won't go into 13, but it will go into 130. And actually that's going to be 5 times, because 5 times 2 is 10. 5 times 2 is 10 plus the 1. That is 11. Subtract and we get 20. Notice my remainder's less than the 22, so I'm good. And then I bring down a 0. 22 will go into 209 times, and I end up getting 198. I subtract, I get a 2. If I bring down a 0 though, 22 won't go into 20, so I have to put a 0 up here to show that it won't go. And then I get a 20, and I bring down another 0, and now I see the pattern. 22 will go into 209 times. I'm going to keep getting that string of 9090. It's going to keep repeating. So this answer is going to be 0.590 with a bar over the 9 and the 0. And if you're not sure, if you don't see after 3 numbers that that's going to be repeating that way, then go ahead and keep on dividing it out and you'll see it. But notice my remainder kept alternating between 2 and then 20. All right, next up we're going to order fractions and decimals. And this can be important when we think of like the stock market. So for instance, it could go down a couple points and up a partial point and then down more. And we can find these trends based on other things that are happening. So this can be very helpful to people who are investing their money. So ordering and knowing when it's a sharper decrease or when it goes down more points or less points can be useful, and they are key indicators for when it might go back up again, when you can make money on it. Woohoo! So when ordering fractions and decimals, we want to convert the fractions to decimals. And then next, we want to graph it on a number line. And yes, this is just one way to do it, but it's real easy to see on a number line, especially if you're putting your hash marks and labeling them. And I'll explain that in a second. So let's say we had an example of order -1/4, 1500ths, -4/10, and 1/5 from least to greatest. Well, if you'll notice, two of the numbers are already decimals, the 0.15 and the -0.4. So really all we need to convert is the -1/4 and the 1/5. In other words, you want to convert them either all to decimals or all to fractions. And the way I'm showing here is just all to decimals. So I'm going to do 1 divided by 4, and hopefully you already know this one. 1/4 is 0.25, but I'll prove it. 4 will go into 10 twice. We get a remainder of 2. And then 4 will go into 25 times with no remainder. So it's -0.25 because it's a negative fraction. And then 1/5, 1 divided by 5, I know that that's also 2/10 because I can make it an equivalent fraction. That's an easy way to think of it, but I'll prove it by dividing as well. So 5 will go into 10 twice. So it's 0.2 or 2/10. Now I'm going to make a number line, and on that number line my biggest number is 0.2, so I'm going to go, let's go like this, 0, and then each one of these hash marks is going to represent the tenths. So 0.1, 0.2, -0.1, 2, 3, 4, I'll label every other one. So -0.5, -0.6 I'll label. And I may not need to go any further than that. I'll see what I'm dealing with. So the -1/4 of the -0.25, that's going to be, this is -0.3 right here, so -0.25 is right there. I'm going to label that above it. That's -1/4. And then the next one I'll do is the 0.2, which is the 1/5, and that would be right here. And now I'm going to do I'll just mark them off as I do them. So -1/4 and 1/5 are taken care of. 0.15, that is in between the 0.1 and the 0.2, halfway. So 0.15 goes there. And then my last one is -0.4. That's just right here. And now they are from least to greatest as I read them from left to right. And that's because my greater numbers or more positive numbers are to the right of a number line, and my lesser numbers are always to the left. So it would just be -0.4, -1/4, 0.15, and then 1/5. All right, well, that wasn't so bad. Okay, let's practice writing decimals as fractions. And when we write decimals as fractions, just write it how you say it. And then reduce. So an example would be 2.08. The correct way to say 2.08 is not 2.08. It would be 2 and, look at where that place value is. This is tenths and then hundredths. So it would be 2 and 8 hundredths, because the 8 is in the hundred spot, or the last digit is in the hundred spot. So 2 and 8 over 100. And then I want to divide by my common factor, so I know that 4 will go into both of these. And I get 2, and then 4 quarters makes 100 cents. So that would be 2 and 2/25. Don't forget to bring that whole number over when you reduce it, because that 2 is the whole part, and this is just the fractional part. So 2 and 2, whoops, that's 2 and 2/25. Almost forgot my 2 there. Now remember when I said that we can write repeating decimals as fractions? Well, I'm going to show you how to do that. No, I'm not going to repeat that. You got to listen the first time. All right, so writing repeating decimals as fractions, whoops, you got me. I repeated it. Our goal is going to be to cancel repeating decimals by subtracting. And the whole idea is if you can cancel out that repeating part of the decimal, then you'll just be left with a whole number. All right, so let's say, for example, we want to write 0.12, where the 1 and the 2 are repeating, as a fraction. Well, I need to cancel out that repeating part. So here's what I'm going to do. My first step is always going to be let x equal that repeating decimal. And then now I'm looking at how many numbers are repeating. So I see that there are 2 repeating numbers. So if I can subtract out that, I need to move this 2 spots to the right, is how you want to think of it. So what can I multiply by to move this 2 spots to the right? Well, this is times 10. This is times 100. Just think of base 10 like with the metric system. So times 10 times 100. So 2 repeating numbers, the 1 and the 2, means that we multiply by 100 because that moves it 2 spots to the right. So times 10 times 100. So now if I multiply that whole equation by 100, that's times 100, that's times 100. 100 times x is 100x, and 100 times 0.12 repeating is 12.12 repeating. Because again, all that did was shift the decimal 2 spots to the right. Now my second step is I want to subtract the first equation. And the reason I want to do that is that cancels out my repeating part. So my first equation was up here, the x equals 0.12 repeating. So I'm going to subtract that out. So if I subtract out that whole thing there, 100x minus x gives me 99x. 12.12 repeating minus 0.12 repeating, this is the fun part, this just cancels out. So you have no more repeating numbers here, because 12 minus 12 there is nothing. I know what you're thinking, but that 12 goes on and on. It's really 12, 12, 12, 12. Well, 12, 12 minus 12, 12 is still 0, right? So it doesn't matter how many 12s you add to that. It's still the same number on the bottom, so it cancels out. So we have 99x equals 12. And now to solve for x, we just divide by 99. It's just a one-step equation. The inverse of multiplying is dividing. And I'm just going to divide by my common factor. I know that 3 will go into both of these. So 12 divided by 3 is 4. So x equals 4 over 33. And then our third step we just did was solve. Solve the equation. Solve it for x. Now this can be a little tricky, but if you just stick to these 3 steps, you're going to be fine. Let's do one more where you have a different number of repeating digits. So for our second example here, let's write 0.8 repeating as a fraction. All right, think about how many spots or how many numbers are repeating. Now, how many times would you have to multiply that to move it that many spots? All right, well, our first step is we're going to let x equal the repeating decimal. And then one repeating number means we multiply it by 10 to move it one spot. So just think, times 10 is going to move that over, so our 0.8 repeating will cancel. So one repeating digit, just multiply by 10 to move it one spot. And now let's do that with the whole equation. So 10 times the x equals 0.8 repeating, and we're distributing that 10 to both numbers there. 10 times x is 10x, which equals 10 times that. Remember, if we just move it over one spot, it would be 8.8, still repeating. And then remember, our second step there is we want to subtract the first equation. So that first equation was up here. It was the x equals 0.8 repeating. So I'm going to subtract that whole equation. And if I do 10x minus x, I get 9x. And then 8.8 repeating minus 0.8 repeating. 0.8 repeating minus 0.8 repeating is nothing because they're the same number. And 8 minus the 0 here, or nothing there, is 8. And then our third step is solve. So just divide by 9, and you've solved for x. X equals 8/9. And actually, something to make you feel a little smart, if you had 0.7 repeating, that would be 7/9. 0.6 repeating, that would be 6/9. 0.5 repeating, that's 5/9. All the 9s as denominators work that same way. So if you only have one digit repeating, it's going to be over 9. So 8/9 is 0.8 repeating. Huh? Repeat that decimal.